Elon Musk debuts revolutionary anti-gravity fighter jet. Musk just introduced the revolutionary anti-gravity fighter jet, which came at a critical time. World nations compete to improve their defenses and secure superior technology. This groundbreaking aircraft, with a major strategic advantage, is shocking the globe. What impact will it have? In aviation, aircraft have capabilities of this amazing innovation. Join us as we reveal Elon Musk's anti-gravity plane. Musk just revealed a big advancement for SpaceX's Starship rocket. Its third test flight attained many of its goals. The two-part rocket successfully launched from Texas and tried to send its top part around the world to reclaim the Indian Ocean. Although radio contact was lost, the business later said it was amazing how far they had come. SpaceX CEO Elon Musk was also very happy with the flight results. Last year, SpaceX's 120 tall rocket launched in April and November, but both times it burst immediately after liftoff. Musk desired a better outcome this time, and SpaceX delivered. The rocket burst to life with 33 engines blasting massively, smoothly completing every stage to enter space on time. The lower booster half split from the ship's top half 2 minutes and 44 seconds into the flight. The ship kept flying over the Atlantic and southern Africa. Along the way, video cameras captured stunning Earth photographs from over 100 miles above. Next was the task of descent for the ship to re-enter for an ocean splashdown. Video footage revealed amazing scenes with gases surrounding the craft before radio communication ended. Soon after, controllers reported the ship was likely lost because it had ripped apart. Not everything happened as planned after leaving the ship. The booster was meant to slow and perform a controlled sea landing, but came too close near Texas, appearing to move too fast, and was lost before entering the sea. The ship was supposed to restart its engine for re-entry, but failed. The causes are unclear and will be revisited once the data is examined holistically. Engineers expect progress on the world's strongest rocket, which remains on track. Musk has promised up to 6 more test flights this year. Starship is unlike any rocket before. Its 33 booster engines produce 74 meganewtons of thrust, far stronger than previous rockets, even those that sent astronauts to the moon in the 1960s and 1970s. If engineers perfect Starship, it could change the rocket game. The design allows for reuse and rapid readiness for another launch. With the ability to carry over 100 tons into orbit in a single trip, it would substantially minimize space mission costs. Starship is vital to Elon Musk's Starlink project, which involves creating a broadband internet network worldwide. Over 5,000 satellites exist, and the new rocket will launch even more. During this trial flight, it succeeded in opening and closing a future-enabling door, the release of Starlink satellites. Starship will assist Musk in achieving his longtime goal of sending people and supplies to Mars for human settlement. The U.S. space agency NASA is one of the most interested viewers. On Thursday, Starship proved crucial to NASA's Artemis program, which intends to return astronauts to the moon within this decade. A unique Starship landing craft will take the crew from moon orbit to the moon's surface, then up again before the astronauts return. However, SpaceX must demonstrate Starship's safety and dependability before that. NASA anticipates this by late 2026. The FAA, which regulates commercial spaceflight in the U.S., declared it would investigate the mission due to the end of booster and ship flights. SpaceX will routinely perform these investigations to see what went well and what needs improvement. This is a common SpaceX procedure. Their first rocket, Falcon 1, was a tremendous achievement as the first privately sponsored liquid-fueled rocket to orbit. SpaceX designed Falcon 1 to launch cheap satellites and reduce Earth to orbit costs, while boosting reliability and streamlining the launch procedure. It also helped test parts and design ideas for the bigger Falcon 9 rocket. SpaceX focused on making a simpler rocket that could transport 450 kilograms to orbit, trying to avoid financial problems by building larger, more complicated rockets. The first stage of Falcon 1 was made of strong aluminum alloy and had one Merlin engine with a parachute system, which allowed the engine to be safely recovered. Improvements with the Merlin 1C engine were utilized in later Falcon 1 flights. Its stage thrust was 92,000 pounds, and it burned for 169 seconds. The second stage was made of material appropriate for extreme cold, powered by a Kestrel engine with a pressure control system. SpaceX initially promised a fixed-price Falcon 1 rocket at $5.9 million in 2005, which was later raised to $6.7 million in 2006. By 2009, the price had increased to $7 million for the Falcon 1 and $8.5 million for the upgraded Falcon 1. Despite being retired in 2009, Falcon 1 succeeded after 5 launches, establishing SpaceX's future. Falcon 9 became vital to SpaceX. It contains 2 stages and can haul medium loads into space. Falcon 9 launched first on June 4, 2010. Its first mission to restock the ISS was on October 8, 2012. Falcon 9 became the first commercial rocket to launch humans into orbit in 2020 and had the most launches in 2021. Falcon 9 has a strong safety record, with 364 successful launches, 2 failures, 1 partial failure, and 1 pre-flight destruction. Falcon 9 is unique because its booster can land vertically for reuse, first accomplished in December 2015. By August 28, 2024, SpaceX had successfully landed the Falcon 9 booster 326 times, with some boosters soaring up to 23 flights. Both rocket stages use SpaceX's Merlin engines, powered by supercold liquid oxygen and kerosene fuel. Falcon 9 has hauled huge payloads into space, including Intelsat 35E and Telstar 19B. In January 2021, it set a record by deploying 143 satellites in a single mission. The latest Falcon 9 variant, Block 5, has been operating since May 2018. Both Falcon 9 stages use Merlin 1D engines. Each booster stage has 9 engines, arranged in a pattern SpaceX calls the octaweb. The second stage has 1 Merlin 1D engine. Falcon 9 can still complete its mission if 2 engines fail by running the remaining Merlin engines longer. Each engine is controlled by 3 computers, constantly verifying each other. The Falcon 9 fuel tank domes are made of an aluminum lithium alloy, with friction stir welding for extra reliability and strength. The inner stage that links the rocket's upper and lower phases is made of carbon fiber with an aluminum core. The separation mechanism has been streamlined from 12 to 3 connection points. Rockets have payload fairings that protect satellites during launch. Since 2019, SpaceX has reused fairings, which return to Earth for later missions. SpaceX employs multiple backup flight computers with fault-tolerant software, using standard parts and a radiation-resistant design. Falcon 9 boosters have extendable landing legs and grid fins that emerge after the stage separates, guiding descent. Early Falcon 9 versions had aluminum fins, later replaced with titanium ones for improved heat endurance. Musk has created something exceptional amid chaos. His boldness led to the development of the X-1 craft, which is constantly scrutinized by the American government. This magnificent automobile, a product of years of SpaceX work, can approach 4,600-mile hypersonic speeds. In conclusion, Elon Musk and SpaceX continue to revolutionize the aerospace industry, pushing the boundaries of technology with innovations like the anti-gravity fighter jet and Starship rocket. These groundbreaking advancements hold the potential to reshape space travel, military defense, and global connectivity through projects like Starlink. Despite challenges, setbacks, and debates over their uses, these innovations demonstrate Musk's bold vision of the future, where reusable rockets reduce space exploration costs and advanced aircraft technologies redefine defense systems. As SpaceX pursues further test flights and innovations, the world watches closely, anticipating the profound impact these developments may have on aviation, space exploration, and even human settlement on other planets. Don't forget to like, share, subscribe, and drop a comment below to let us know what you think.